Hello everyone and welcome back. Today I'll be talking about working with aqueous solution. I will show how to calculate molality, molar concentration and molarity. I will provide a link in the description of the video where you can download the material either on our blogger or our website. There are few terms that we use when we are working with solutions. The first term we use is the word concentration. We refer to the concentration as the quantity of the solute that is dissolved in a certain amount of solvent. If we are talking about dilute solution, this means we are talking about less amount of the solute, and if we are talking about concentrated solution, this means we are talking about higher concentration of the solute. We can express the concentration quantitatively by giving the mass percentage of the solute. Our first concentration unit is the molar concentration. The molar concentration or molarity is defined as the number of moles of solute dissolved in 1 liter of solution. It gives advantage when we are preparing solutions because we can relate the amount of solute to the volume of solution that I want to prepare. So we could say that molarity is actually equal number of moles of solute over liter of solution. Let's take an example. How many grams of potassium dichromate are required to prepare 250 ml solution whose concentration is equal to 2.16 molar? First, I need to calculate the molar mass of potassium dichromate. So my molar mass is equal to multiplied. I have 2 potassium atoms. Each one is equal 39. Let's take an example. How many grams of potassium dichromate are required to prepare 250 ml solution whose concentration is equal to 2.16 molar? First, I need to calculate the molar mass of potassium dichromate. The molar mass of potassium dichromate would be equal to 2. I have 2 potassium atoms, so the 2 multiplied by atomic mass of potassium, which is equal to 39, plus for chromium it is 2 multiplied by 52, and I have 7 oxygen atoms. This means I have to multiply 7 by 16. The sum of that is equal to 294 grams. So we have seen that molarity is equal number of moles over volume in liter. This means if I know in here I have the volume and in here I have the concentration, from the volume and the concentration I can calculate the number of moles. So the number of moles would be equal to my molarity, which is 2.16, multiplied by the volume have to be in liters, so it is 250 divided by 1000. From that, if I calculated that, it would be equal to 0.54 moles. So the number of moles is also equal to grams over molar mass. From that, I can get the number of grams by multiplying the number of moles, which I got from the previous step, by the molar mass, which I got in the first step, to get my grams. So the grams of potassium dichromate would be equal to the number of moles, which is equal to 0.54, multiplied by my molar mass, which is equal to 194. That would be equal to 159 grams. Let's take another example. In a biochemistry assay, a chemist needs to add 3.81 grams of glucose to a reaction mixture. Calculate the volume in milliliter of 5.53 molar glucose solution. So for my first step should be calculating my molar mass of glucose. I know that the formula of glucose is equal to C6 is H12O6. So I have to multiply 6. I have 6 atoms of carbon. Each one have atomic mass is equal to 12. And I have 12 hydrogen atoms. Each one is equal to 1 atomic mass. And I have 6 oxygen atoms. Each one is equal to 16. So the sum of that would be equal to 180 grams. If I know my molar mass and I know the number of grams, I can calculate the number of moles. So the number of moles would be equal to my grams, which is equal to 3.81, divided by the molar mass, which is equal to 180 grams. This would be equal to 2.114 multiplied by 10 to the power minus 2 moles. So now I have the number of moles and I know my concentration. From that I can calculate my volume. So my volume would be equal, remember that I need my volume in milliliter. So my volume would be equal to 2.114 multiplied by 10 to the power minus 2 divided by my concentration, which is equal to 2.53 molar, here moles, and I have to multiply by 1000 to convert the mil into liters. This would be equal to 8.36 mil. The second way of expressing the concentration is using mass percentage of the solution. The solution concentration is sometimes expressed in terms of the mass percentage of a solute. That is the percentage by mass of the solute contained in a solution. Or it can be defined as the ratio of the mass of the solute to the mass of the solution multiplied by 100%. So my mass percentage of the solute should be equal to the mass of the solute divided by the mass of the solution multiplied by 100%. Remember, this is the mass of the solution, which should be equal to the mass of the solute plus the mass of the solvent. Let's take an example. A sample of 0.892 grams of potassium chloride is dissolved in 54.6 grams of water. What is the percent by mass of potassium chloride in the solution? So now I have the potassium chloride grams and my solution, the water only, is equal to 54, and I need to calculate the mass, percent by mass of the potassium chloride. So percent by mass would be equal the mass of the solute, which is 0.892 grams, divided by the mass of the solution, which is equal to the 54.6 plus the grams of the potassium chloride dissolved, which is 892. All of that should be multiplied by 100, and this is equal to 1.61%. The third way of expressing concentration is by using mole fraction. The mole fraction is a dimensionless quantity that expresses the ratio of the number of moles of the one component to the number of moles of the all presented component. So mole fraction of component A should be equal to the number of moles of A divided by the sum of moles of the whole other component. The last way of expressing concentration is by using the molality. The molality of a solution is the number of moles of the solute per kilogram of the solvent. This means molality is the number of moles of the solute divided by kilograms of solvent. For example, if I have 0.2 moles of ethylene glycol dissolved in 2 multiplied by 10 to the power 3 grams of water. 2 multiplied by 10 to the power 3 means grams of water means 2 kilograms of water. So if I needed to calculate my molality, it should be equal to 0.2 moles of ethylene glycol divided by 2 kilograms of the solvent, which is the water. This means it is equal to 0.1 m ethylene glycol. So the difference between molality and molarity, the molality is defined in terms of mass of the solvent, while molarity is defined as a term of the volume of the solution. Let's take an example. Glucose is a sugar that occurs in fruits. It's also known as blood sugar because it is found in blood and it is a body's main source of energy. What is the molality of a solution containing 5.67 grams of glucose dissolved in 25.2 grams of water? If I looked here, I have the grams of glucose. From the grams of glucose, I can calculate the number of moles. So first I need my molar mass of glucose, which is equal to 6 multiplied by 12 from this formula, plus 12 multiplied by 1, and I have 6 oxygens multiplied by 16. The total should be equal to 180 grams. So the number of moles should be equal to number of grams I used, which is 5.67 grams divided by 180 grams molar mass of the glucose. This would be equal to 0.0315 moles. So I can calculate my molality, which is equal to the number of moles of my solute, 0.0315 moles, divided by the grams of my solution, 25.2 grams, multiplied by 1000 grams divided by 1 kilogram. This way, this way I can convert the grams into the kilograms. This is equal to 1.52 molar concentration of glucose. In here we could see a comparison between the different type of concentration units. The first one is a molar fraction. We usually don't use this one for titration or gravimetric analysis, but we use it when we are calculating partial pressure of gases, while molarity is used to measure the volume of the solution using calibrated volumetric flasks instead of using weight of the solvent. It is dependent on the temperature. That is why we can, if I have a solution that is affected by the temperature, I can use instead the molality. The molality doesn't depend on the temperature because it is only concentration, and it is expressed in moles for the solute and the solvent. Percent by mass also doesn't depend on the temperature, but it is a useful way because it is a term that we expresses only a ratio of mass of the solute to the ratio of the mass of the solution. By that we don't need to know the molar mass of my components. Let's take an example. Express the concentration of 0.396 moles glucose solution in molarity. If I know the number of moles here, and I know that the molar mass of glucose is equal to 180 grams, this means I can calculate the mass of the whole solution. So the mass of my solution should be equal the mass of the glucose I used, which is equal to the number of moles of glucose multiplied by 180 grams of glucose, plus the mass of my solvent, which is equal to 1000. I will assume that I'm using only 1 liter water, grams water, which is equal to 1071 grams. Now I know the number of grams of my solution. From the relation volume is equal to mass divided by density, I can get the volume of my solution. So it will be equal to 1071 divided by my density, which is 1.16. This means my volume is equal to 0.9023 liter. Now I know my volume and I know my moles. From that I can get the molarity. So the molarity should be equal to the moles of glucose, which is equal to 0.396, divided by the number of liters, which is equal to 923 liters, equal to 429 moles per liter. So from that I could calculate my molarity. Moving from this, we will move to diluting our solution. Usually we use in laboratory stockroom, we use what is called stock solution. A stock solution is a very high concentrated solution. Before working with our experiment, we usually do what is called dilution. We dilute our concentrated stock solution into less concentrated solution. When I prepare diluted solution, I should keep in mind that the number of moles doesn't change during dilution. So the number of moles in my first concentrated stock solution didn't change when I diluted my solution. So if I said that the number of moles, I know that the molarity is equal the moles divided by the liter of the solution. This means I can get the number of moles on that side. It will be equal to the molarity multiplied by the liter of the solution, and it also means that the initial molar concentration multiplied by the volume is equal to the number of moles, which is in case of diluting my solution would be equal to my final concentration multiplied by my final volume. So M initial multiplied by V initial should be equal to M final multiplied by V final. Let's take an example. Describe how we do prepare 5 multiplied by 10 to the power 2 ml of 1.75 molar sulfuric acid if you have a stock solution with 8.61 molar concentration. So this is my initial molar concentration, and this is my final molar concentration, and this is my final volume that I need to prepare. For that, if I applied the relation Mi multiplied by Vi should be equal initial, M initial by V initial equal to M final multiplied by V final. For that, my initial volumes should be equal to my final volume multiplied by my molar concentration, which is 1.75, divided by my stock solution concentration, which is equal to 8.61. This should be equal to 102 ml. So if I took 100 ml of my from my concentrated solution with this concentration, I should be able to prepare 5 multiplied by 10 to the power 2 ml of this sulfuric acid concentration. By that we came to the end of our video. Next video will be about gravimetric analysis.